Hi, how are you? Doing well, thank you. You're here. That's okay. Unfortunately, maybe fortunately, I don't know. This last part of the workshop, you do it in Python, you can do it in R, you can do it in a variety of things. I'm going to do it in MATLAB, which is a software that you probably don't have. You can get it as a USC affiliate. So I'm hoping in MATLAB I can just focus on the concepts and implement it in R or Python, which is you're more familiar with. It's just math syntax of that. Yeah, no, I understand. I'm pulling a mute cat on you. Casey is not. Casey won't be back for about 2 weeks. She did a position. I don't know the details of the position from SAS. So she's working and finishing her PhD. Wait for 5 minutes or so. I don't machine learning part. A lot said that they want to attend. They couldn't meet this other time week actually. There were not people who are attending online, but there seem to be a lot of people who are interested to kind of know what it is. So we'll go through all recorded, posted. Um, I don't usually think they just may stick you with a $8 ticket. that's actually being brought to WebEx or not. All right, guys, let's go ahead and get started. What I'd like to do today is just in a very introductory fashion, talk about machine learning. And from there, do is switch to MATLAB, which is kind of environment I'm going to work in, and give you some examples of the simplest machine learning techniques that we can actually incorporate and build gradually towards a more complex one. So starting, okay. Forward. All right, so familiar already with the process of these, but in case there are people who are going to attend in the future, I'd like to go over the basics a little bit. So we've got 5 one-hour sessions. Each one of the sessions, I'd like to start with a little bit of theory, but I don't want to get too much into the theory and get stuck in weeds of mathematics and whatever else. But just give you the concept of how these different machine learning techniques work. From there, I'd like to maybe dedicate one-third towards theory, towards actually hands-on practice, what it is that they can focus on, what they can do, what are the advantages and disadvantages of methods. So going forward, one of the 3 things that I thought would be useful to cover is the k-means clustering, binary decision tree, and artificial neural networks. If time allows, we may go to principal component analysis and support vector machine. But we will probably not have time to go there. We can, although, discuss it maybe informally a little bit if needed. But I'd like to cover, maybe start with binary decision tree, and from there maybe go k-means clustering. Casey kind of gave examples of k-means clustering in our session last week. So if you guys want to, you can take a look at that for detail. And I'm going to do, unlike other approaches where people get actually experimental data, like the data that are coming from actual data, I like to synthetically generate data in order to illustrate some of the topics that I want to show. So I'm going to use a mix of experimental and synthetic data. So machine learning software, there are many platforms you can use. You can use R, you can use Python, you can use C++, and just about other popular language you can think of. There is machine learning tools there. So R and Python were the previous workshops that we covered. You would think I would naturally go there. But unfortunately, to actually do these, you would get stuck in the syntax of R or Python. I don't want to get stuck on syntax. I want to work on the concepts. So for that reason, MATLAB would be a very useful environment. You'll see why many of the things that I'm going to do, it's really not going to interact with MATLAB. I'm just going to click on just GUIs, interface. Expensive. MATLAB for companies, it may cost $10,000 to $100,000 for software. But honestly, for USC affiliates, it's free. We have site license. You can get it installed on any of your computers. Students, staff, faculty. There are toolboxes you can use, so it's useful. Students, in general, if you are not part of USC and you're just a student who does not have site license, you can get it for $99. There is a MATLAB-like platform called Octave. It's the open source version of it. And many will work, although it doesn't have as user-friendly graphical interface. So it becomes a little bit more difficult. I care, but then again, stuck in syntax. So we're going to do MATLAB. So machine these days is actually a very hot topic, and when you talk machine learning, people just automatically kind of mix in their kind of synonymous to it as artificial intelligence, deep learning, neural network. These have overlaps, but they're not the same thing. So they kind of overlap, I don't know, 80%. But machine is a branch of artificial intelligence, and artificial intelligence itself is something around since 1950s. And it has gone through spells and phases of being very active, very hot, very funded, to the point that then people find some limitations and they lose interest and move on. So the form of artificial intelligence is rule-based, that you just come up with a whole bunch of rules that then you can implement in the form of a program. And I mean, let me just introduce some of the very first one. It's kind of a conceptual problem that I would like you to start thinking. For example, let's say I have to identify the gender of a person based on their height, weight. So operation there that men may be heavier, taller than women in general, but so you're able to some extent to make that assessment. But under some rule, you can just come up with a rule that if a person is more than 230 pounds, taller than 6 foot, you can just call them male, and anything less than male. So you can just essentially come up with a set of rules. So in that expert rules or the systems or rule-based was basically fostering on that kind of approach, where then into a number of programming languages that were very good at capturing these complex rules and if statements, which kind of they actually died over time. Maybe not as popular as it used to be. Methods can be classified based on a variety of methods. So input, on the basis of what input is used, machine learning tool, what kind of output it produces, or whether there is any kind of human involvement in the process of training. So some of these are different branches of machine learning, but in common ones that you will encounter is supervised learning versus unsupervised learning, and whether you're engaged in classification versus prediction. So these are slides to actually discuss as we go along this week, other branches of it, but I'm going to actually, let me see, somebody might have joined. So I'm pronounce your name, Eltayo. Can you hear me? Yes. Okay. Well, if you can't hear me, have any questions? I'll keep an active view of the. Also chat me if you would like, but interrupt as you wish. Okay. So go ahead and just briefly cover each of these concepts. I'm not going to worry about supervised, unsupervised until a little bit later in the workshop. But for now, let me talk about classification versus prediction. So the question of classification is very simple. It's just like the example that I just said, identify the gender of a person based on their height, weight. It essentially identify the classification of an observed input pattern. So input pattern in that example would be height, weight. Classification would be whether you want to assign that person to be a female or male. The exact classification problems would be identify gender of a person, identify responders to a drug based on genetic makeup. So whether a person has a genetic disposition to
to respond to a drug, the answers to that question would be yes, no. Identify a chemical compound based on human symptoms. So depending on whether your eyes are itchy, your nose is runny, you may be able to identify the chemical to chemical number 1, 2, 3, or 4, and so on and so forth. Identify calcification in arteries, whether the calcification in arteries exists or not. So that's a yes, no question. So categorical outputs, that the output of the system is either a yes, no, or is either a class 1, class 2, signifying female responders, not responders, or it may be a chemical 1, chemical 2. These are essentially anything that the output of the system is categorical is essentially a classification. In contrast, you may be able to quantify the output of a system based on the input. So, for example, predict the future value of a commodity, so stock market prediction. You might want to predict how much Microsoft stock is going to be worth a year from now. So that's not a yes/no question anymore. That's not a female/male anymore. That's a number. You want to present a number that's a continuous value. Maybe from 0, you may want to put a cap on it, like let's say 200, 300, 500, but it's a number. It's no longer just categorical. Predict the blood glucose given a treatment. So you want to predict a particular drug that you want to deliver to a person. Going to respond to this drug, yes, no, that would be a classification problem. But how much is it going to change their glucose level is going to be a prediction, where you're going to have to come up with a number. pH level of an environment given the changes, you need to control the pH value in some industrial things. You may want to just quantify how much of what material you need to add in order to maintain a certain pH. So these are of the system are continuous, and this is called prediction. Now, I think that's what I have. And what I do is jump into a decision tree and start gradually talking about machine learning as binary decision tree being one, and use some of the tools that MATLAB has to offer. So far. Okay. What I'd like to do at this point, I'd like to switch to MATLAB. And I posted a couple of example data for MATLAB in as part of the invite. I don't know if you guys got that. I don't know if it was included in the emails or not. If it is not, let me know. I'll share them with you in a different way. Bit of background in MATLAB. So MATLAB, from the engineering perspective, this historically is a software that's used in the engineering and computer science realm. Although in recent years, as far, MATLAB still has a strong hold in the engineering arena. Now, MATLAB syntax is very friendly. Mathematically friendly. So it's not as desired by people in the field of science as liberal arts, but engineers and mathematicians really dig it. So, for example, some of the things you do is very similar to R, with slight notation. I can generate data by invoking random numbers. It's just going to generate random numbers. I can give it 100, and what it is going to do is going to generate numbers for me in a random fashion. The value 100 that I gave basically says matrix of 100 by 100 that will that is the generated numbers. In my MATLAB interface, let me start from that. This is basically the contents of my subdirectory where I'm pointed at. The history of the stuff that I have done. So this may be useful in order to if you have a flex command of some sort, you can actually repeat it there. It shows me my workspace. This is a collection of all tables that I have loaded, and everything that correctly is in my workspace. Now, you see this variable answer. I can double click, and it brings it up in form of a spreadsheet. I can look at it. I can play around with it. I can just play with it. Now, is based the result of the last command that I executed, which generate random 100 numbers, a matrix of 100 by 100. If I just create a column of 100 numbers, I can just give it, which was 100 by 1. Now I just have a column of 100 random numbers. If I want to write 2, I could do this. I can capture the results into a variable. Let's say data is then becomes random. And now I have data created here. I can again double click, look at it, play around, do whatever I want to do. But most likely you would want to do at first is to plot them. A variety of ways you can plot the data. I'm just going to go the simplest route. That is just point and click kind of thing. So you can click, go to plus, and say, give me a scatter plot. Scatter plot will be generated, data plotted. You can go to change the axes properties, which my x to go from 0 to 10, my y to go 0 to 10. This is something that I'm going to do. So my data is just distributed between 0 and 1 in both dimensions. I can delete another set of data that is, I'm going to call it data 2. It's going to be a set of randomly generated numbers. Well, I'm going to shift everything instead of C is between 0 and 1. I'm going to shift everything to be like up here somewhere. So I'm going to shift 3 and 3. And can plot, concurrently plot both sets of data to show that how they are separated. But to do that, if I click data 2 and say scatter plot, it will replace the previous plot of data with the plot of data 2. And plot my data again. And if you click on, it will keep have and it just add on to it. So I'm just going to now add the plot of data 2. You can see this is data that I generated at first. This is the data that I generated second, and everything is shifted by that value of 3, 3 that I was talking about. Now, you can control their statistical attributes, and from there proceed forward in statistical analyses or derivation of machine learning. You can do linear algebra. You can do a variety of things very, very straightforward, but that's not the focus. So what I'm going to clear this workspace. I'm going to load my example 1. In my example 1, I have class 1 and class 2. Each one of them has 1,000 points, 1,000 rows, and there are 2 columns. You can take a look at it. So there's data, and there's 1,000 of them. I'm going to pretend this is my class 1, class 2. So my class has 1,000 observations. My class 2 has 1,000 observations. And that I have separated them into 2 different classes essentially makes it somewhat supervised learning. Supervised meaning someone looked at the data and has already decided that this set of data belongs to class, let's say, male, and this set of data belongs to class female. You don't necessarily always have the luxury of knowing that ahead of time. So that becomes unsupervised learning. But focus everything on supervised learning and maybe discuss some of the unsupervised learning towards the end of the workshop. So here, you can and you can think of class 1 being men, class being female. You can so however you want to think of it, I'll keep it abstract. I'm going to even call it height weight. I'm just going to say feature 1, feature 2. In pattern recognition machine learning, so what the key concepts that we talk about is feature. And in particular instance is straightforward height weight, but that doesn't have to necessarily be the case. You may see at later time, I may take this height, weight converted to other abstract features where then the separation of space works a lot. Machine learning techniques work a lot better. So them features. My feature 1 is my feature 2 that produce class 1 and class 2. Now the question is, are features sufficiently informative that I can identify class 1 members from class 2 members? And that is really the core of machine learning. All are in existence. They operate in answering that question one way. The approaches are different, but the general principle of what you're trying to do remains the same thing. So let me plot them for you. First, to plot this data, this is my class. I'm going to hold on so I can concurrently plot data from 2. So class 1 and class 2 are clearly separated from each other. And machinics, the way they operate is to draw what's called a decision boundary. A decision boundary is such that when you're on the decision boundary, you belong to class 1. When you're on the other side of the decision boundary, you're in class 2. And you can do that in this particular being so separated from each other, you can do it very easily. So for example, decision boundary may be your decision may be this particular line. You can say on the right side of that line, you belong to class red, whereas if you're on the left side of that line, you belong to class blue. But that boundary is not unique. So that's one. The other one could have put in there would be decision boundary, where if you belong to class red, if you're below it, you belong to blue, or you could have yet drawn the boundary like this, that if you're to one side of it, your class red, to the other side of it, your class blue. Between machine learning techniques at this point, at least a couple of sessions that I'm going to talk about, essentially how do you draw these lines? Becomes, in this particular instance, it's very clear, but I'm using this as an illustration purpose, and I'm going to gradually move these two closer together to show shortcomings of some of the, at least the earlier versions of machine learning. So is it clear? Two things. My feature space at this point is 2. That's why I can easily have the luxury of plotting it. How it goes 3, 4, 5, or more, you no longer have the luxury of plotting and looking at it and say, oh, clearly they are separated, therefore I can draw a line. Because you cannot visualize it, then you have to rely on your numerical methods, on machine learning techniques to blind you, to create the separate space and ask the question of, are you successful? Did you do it? To what extent? So my feature space, I have 2 features, and they are clearly separated. Now, I want to set these to machine learning, and as the very first method of machine learning, I'm going to implement tree. Okay. So decision trees operate in the following way, and what I'm going to do, I'm going to join these 2 data sets together. How? Yeah. It was in the email. Invitation. Is it there? Let me ask, when did you get the invitation? So I sent it in twice. Once was yesterday, I think. That one did have the attachment, and I modified it this morning that did have the attachments. you get it? Okay, so if you wait, did you get Tommy? Let me. And it doesn't. I see. Let me take a look at something here. All right, let me give you that's what I will do tomorrow. Tomorrow's meeting, I will just have to send a separate email. So I'm wondering, what is the usefulness of attaching something to that WebEx invitation, and if it's not getting to it? So let me just do preparation of the data. So what I have here, I have concatenated C1 and C2, so the down next to each other, such that 1,000 plus 1,000 has become 2,000. And I have a third column to it, which is my class. Now, if you look at class, the first points say class 1, because they all come from class 1. And then 1,001 word are class 2, basically say the points 1,001 all the way to 2,000 belong to class 2. So I created all that and I put it in data. So the first 1,000 points come from class 1 with the designation of class 1, and after 1,001 all the way to the end is from class 2 with the designation of it belonging to class 2. What I have, these are the features that are input to my classification, and I want to come up with a way of classifying things as class 1, class 2 appropriate. Here in the right place, you can go to apps. Now, almost all of the classification techniques that you would want to play with, at least, they're all right up here. You can play around with them with just clicking on buttons, and that's why these are very instructional in trying to learn the method and play around with it to see how they work. So I'm going to start classification. I'm going to start a new session. In my new session, I'm going to select data to be what I'm looking at. Column 2 are the two features, are my predictors. They are the features that are going to be input to my classification. And column 3 is going to be the response or the results of my classification. So that is done. Now the question is, what kind of a classification do I want to deploy? So the data is the same data as before. Now, this arrow brings down a variety of the classification methods. So linear discriminant analyses, logistic regression. You can see there are many different things available to you. At this point, I'm going to focus on the decision tree. So I'm going to select the course because this particular method, this particular data set is fairly straightforward, easy. All you have to do is just click on train, and it's going to produce the results that the training results. To do that, it goes through, says 100% accuracy in identifying the two classes. So it did. It has some mechanism internal. It's not revealed to us yet how, but it has managed to identify these with 100% accuracy. So at this point, I'm not any more detail about what its internal rules are. You need to export this model. You can use it to do the classification classification you can use, or you can dig a little bit more into it and identify what exactly is it doing. I'm going to export it. I'm going to come and do this iteratively with a little bit more complexity to it, but I just want to go through the whole process, show you the bells and whistles, and then we'll come back. So export, it will ask for a name. I'm going to call it decision tree. It's saved. So if I go to my workspace now, I have a decision tree. Decision object. So click on it, just like if you remember from R, everything had multiple attributes, multiple things in it. It has all of these entities. You can go into each of them, and all of them have more code than others. These are all simple. So classification that has more content to it, that has a variety of things embedded there. How it did it, and how you can use it for classification is all embedded in there. So to view the rules, what are the rules implemented in your classification? So you can say view, and give it my decision dot classification. This a set of if statements basically tells you how it is making its decisions if you wanted to look at it in a programming fashion. But this is something you're interested in, you just look at it. So in a little bit more readable to human eye, indicate its mode needs to be graph. We'll come up with a decision tree. And this is the tree that it can do. There was, let me see if I can bring everything together again. This was the figure discussed. You could separate the space based on vertical line, horizontal line, or a diagonal line. And this was the MATLAB perform. And they decided to do this is based on column 1, which is this guy. It drew a decision based on the point 5.1. 5.1 is somewhere here, this vertical line. If less than 5.1, you belong to class 1, which is blue. And greater or equal to 5.1, you're in class 2. So in a particular case, the decision boundary that it put in place was based on point threshold of 5.1, which is a vertical one. Yeah. It will 5.1. We can repeat it again. So the heuristics of it is deterministic, meaning that in such a simple case, when it runs, it always converges given the same data. Try it and see again. And decision that it has put together. Any questions so far? You can decide that you wanted for the same session. Now you want to decide that you want to run a find tree, and you train it. Now you have a particular mechanism. You can then export it, and you can do everything that I just showed you. You can just repeat it. Or know what principal component analysis is. In one of these, you can turn principal component analysis on or off. Then you can forward. For now, I'm just not going to worry about it. So here, if not, I'm going to just open up the second set of example to see what is a little bit more challenging. Go forward without fear. Just proceed. Okay. So I'm going to clear this particular data set. I save it as example 1. So, and I've already kind of combined the data together, and I was trying to, the reason that I have C1 and C1, I was trying to tinker with it to make it work. So let's show you C1 and C2. So again, I can, let me just kill this too. So remember this was the first one. Let's see if it will work. C1 scatter plot. I'm going to fold that on. I'm going to plot C2. As you can see, they are a little bit closer to each other. I no longer of clearly separating the two of them by drawing either vertical or horizontal threshold of separation. I can do a diagonal line by drawing a line right splitting these 2 points. So now I have combined everything into this data set. Data is a size 2000 by 3 because C1 and C2 have nated together, and a third column has been added to designate their classification. And I'm going to start a classification routine based on this particular mechanism. So classification again. I'm going to select them. And the first ones are going to be my feature space, and my third column is going to be my response or the data or the classical outcome. And start. Of particular interest, you might want to keep an eye on this particular point and the other one. So if I was to draw a line right through the vertical space here, this particular point would be problematic. If I was to draw a horizontal point, so these points, the ones that would be above and below the 0.5 line would be the problematic one. Gain or visible? Net sum is equal to 0. Okay. So I just start again. So this particular time, I do another course 3, and I train. And now you can are these particular analysis now. So you are these 2 points that as X's instead of dots, and those are ones that are right now in question as to where they have been misclassified. So these 2 ones that have been misclassified. Again, you can export its decision tree, and you can go in and ask the question of view decision tree. And you want to make sure that mode is graph. So now you can see it has performed the following. It has become a little more clever. So let's do this method. You may begin to see what may potential disadvantages of binary decision tree, but it's not complete at this point until you start looking at it. So the first question that in your binary decision tree is based on column 1 with a threshold of 2.7. So at 7, approximately here, so to insert about 2.7 line is drawn. And it is, are you on the left or on the right side of this thing based on this tree? The question that you're asking is based on column 2. Column 2, the value of 0.72. So 0.72 approximately is going to be, I don't know, maybe here. So this decision has been made. And it's the following. So if you are on the left side of the first line, or the bottom side of the second line, then you're class 1. If you're it, you're class 2. The meaning of these two branches are. Now, the other side does a similar thing. So if you're outside of the first line, and you're on the right side, and you are, so this boundary on this side is a little bit different. So it's at 0.1. It's right about so it draws a boundary. So if you on side of a particular line of 2.7, you are below it, then you're in class 1. If you're above it, then you're in class 2. So it really draws these thresholds that combines together in order to decide how to combine it in order to put you in the right place. Do you see the limitations of decision boundary is? Anybody? Anybody? It does slanted line. Everything is vertical up and so if your space is not cleanly separated by making these binary decisions, vertical, horizontal threshold, it fails basically. And if you have questions, I want to move on to something like that in order to demonstrate one of them more clearly. Should I do? All right, maybe that again. So if I were to let me do this one. Save this. And I'm going to close it. Space. Get example 3. So on the same thing in here, do class 1. Let's make a new figure. So your data could be like this, and you can clearly see now point binary decision tree is going to have issues. You can draw a line somewhere here to separate things, and then another line here to separate things. But you're going to have there's going to be issues related. The optimal cluster would draw a line like this. That's slanted and really separates the two. That's what we're looking for. So we load this data into my classification method. Column 2 with the column 3 being our response. Start. If I just make a decision, let's just do a core. It doesn't make a difference in this particular case. So you can see that there are points that are misclassified, and you ask the question of how your decision. Decision becomes more complex by dissecting the space in vertical horizontal lines. But if you were to then see what it is doing, so it's saying first decision that you're making is based on column 2. So based on column 2, a threshold of 5.38 is established. So that would be 0.38 be something approximately this. You are above it, above it, your class, if you're above it, you're class 1, so all of that. If you're below it, then column n, you make decisions based on column 2, and column 1. So it just essentially draws all these lines, dissect the space, and makes a decision on whether something is how it can do its best. But at this point, you're just not going to be able to do that. The optimal line is a diagonal line that optimally separates the space. Now, so I'd like to do another example to illustrate. If you guys have points, questions, let me go ahead and ask me. If not, I can move on to something a little bit more complex. So when you go through the command line to actually create your own you'll have many different parameters you pass. One of them is the number of splits that you allow. Splits that you allow, if you restrict that, so it may have, we can run it and take a look at it. A tree may have no 10 splits. So in this case, you have 1, 2, 3, 4 splits. You can have 10 splits, 20 splits, 100 splits, and you can see the complexity of your tree grows such that it puts lines. It may be able to just corner one single point at a time, create at the bottom of it, you have 2,000 visual leaves. So that would identify a single point at a time in this case. But the more split does not necessarily guarantee that you're going to be able to do every single one of the points. So let's look at it. Like tree, so all of these actually have the same thing. So at some point, you're just not going to be able to make it work. And something I felt I didn't mention is that how does this even work? Like for example, in this particular case, it takes column 2 as a starting point, and some other ones was column 1. That might be useful to actually discuss. So the number of splits that it does, it can is at some point the algorithm cannot benefit from additional splits. So fine coarse medium is related to how many number of splits you limit it to. The algorithm works. I didn't comment on that one. So set all your data. Focuses on the column that it considers to have the most information. I guess I have that here. Select formative feature of the problem. So look, column 1 looks at column 2. In this particular case, you have additional features that looks at every one of them. And decide which one has most information in it. And its information then kind of varies. Entropy, or you can see variation. If you have a column that varies quite a bit in it, you can assume that there's information in there. A column that's constant between all classes, then there's no information. I could actually throw a third column in here that is just a 0 for everybody. If it's 0, then it has information. There's no point to do anything. So it takes the has most information, separates optimally, so it comes up with a value that optimally separates the two classes based on that one feature alone. And once it has that, it removes that feature. So column 1 is now done. Then it looks at the rest of the data. So once the most informative column has been like threshold established, what's the next one? Then it moves to the second feature, third feature, fourth feature, and so on. So it just dissects it down. Method. Let me show you one last thing and go adjourn for today. You can also this particular Weiser chemical matrix. Let me clear space. So here is one of the data sets we have worked on in the past. So this is of all data, all the chemicals that have been identified to be something that people can come in contact with. This is all the chemicals. There are 300 of them. They are represented 79 signs and symptoms may cause if you are exposed to this chemical. And one indication of the symptom, 0 is the absence of it. Now, this what's out there asks you 79 specific questions. Do you have abdominal discomfort? Yes or no? Do you have abdominal yes or no? And usually asks every one of these 79 questions in order to uniquely identify what the chemical is. Question that one can ask, do you need to ask all 79 questions in a linear fashion? Is it one question that's most informative to ask first and there to decide? If you do that, you can do exactly the same thing. You run all of these 311s, whereas these 70 columns are your in, and your output would be this one, which is the name of the chemical. If you do this, you will get this. The questions that you can ask is actually, you can create a whole binary decision tree that you can ask the question of you can start here if you like. Have hearing loss, yes or no? And from there, if you do, then whatever chemical is, that's what you're exposed to. If you can just go down the tree. If you do and balance it, so it doesn't have such an imbalance here. The left side of this tree is just one node. The right side of this tree is something. But if you balance it such that left side, right side are equal to each other, you usually come up with the following. I forget how to use. See this. This is tree that is put together in a balanced fashion with limited number of prunings. See that so every one of the decision points is a symptom that you ask the question of yes, no. And at the bottom, all the leaves are individual chemicals. You cannot see those because they're kind of congested, but that's essentially what's happening. You can see that from the bottom, to navigate your way through is only 9 or 10 questions. So you can, this first symptom, you can ask that question based on whether yes or no. There's a second question that you can optimally ask. So if you're doing that, you only need to have 9 or 10 questions to get to this bottom very leaf instead of 79 consecutive questions. If you order your questions in an appropriate fashion, you can do this in 10 questions, 79. So for somebody in distress, this becomes a very critical thing. Instead of asking 79 questions, you ask 10, and you find the chemical they have been exposed to. So at this point, what I'm going to do next time, I'm going to see if we can approach these from linear discriminant analysis and from k-means clustering. So that becomes a little bit approach than just binary decision tree. They actually transcend some of the shortcomings of binary tree, and from there we're going to go, I think, from there into maybe neural networks. So if there are no more, I'm going to conclude session. Once hold on. There are two things you're talking about. One of them is the tree being balanced. That's a completely different thing than is it robust, right? Sure, you're asking. Let me just say two things then. So the balanced tree, when you draw your tree like this, okay, so it gives the impression that this is the first question you want to ask, that very top, which drawn is. And that would be the root of your tree, and the deepest point your leaves of your tree. One point where you can, if you can imagine, I click this guy and pull it up, and let this be the first question, and these all fall on the left-hand side, and the rest of it fall on the right-hand side. Any of these nodes, you can click that, pull it out, and the rest of your tree is dangling from that. So the general idea of building trees is that there is one of these nodes that you can identify as the root, such that the branches and right branches have the same number, approximately the same number of splits and numbers. Balanced tree. And one of the exemplary versions of this is red-black tree. So essentially, that's a matter of restructuring the tree such that left side and right side is as many number of depth essentially. And in this instance, what this does, whatever the chemical is, you can identify it in one question. So that one is optimally, this tree is optimally designed for this guy. But down here, whatever chemical is down here is suboptimally. You have to ask all of these questions in order to get. So even you kind of fish out the one that's left side is equal to right side. So that's when in 10 or 9 questions you can get to every one of the chemicals instead of 10 to 20 here. That's of balance. Now the question is that trees, decision trees in general, do have that problem. That becomes their issue. Also, not only related to this left-right, that the decision boundaries are vertical, horizontal, but all they are dead set. So the moment you, in this particular instance, for example, up here, the steering loss is, if you do have it, you're going to off in this right branch, and branch is completely eliminated. So it works, but for erroneous data that originate from humans, bad idea. Nobody is going to have the exact same symptoms. So it's just sufficient for you to make a bad decision. One spot is completely gone and unrecoverable anymore. You count it, you can kind of make these to be probabilistic approaches. But that's necessarily exactly just a binary decision. But the shortcoming of binary decision tree is that bad data gives you the wrong path. That is correct. Right. In this particular case here, you can see there was only one chemical that had a 0 answer to this, and everybody else was 1. So, and I think at this point the problem is in the drawing of the tree. It's not necessarily in the way the tree is put together. I think node of the tree might be this guy. It's the visualization. Right. It has the number of distribution of 1s and 0s in that particular feature. Let me stop. We'll do discriminant analysis and k-nearest neighbor or k-means clustering next time, and from there we'll maybe to neural networks. Okay. All right. Thank you, folks. See you later.